In this video, we're going to use related rates to solve problems involving distance. It says a van is traveling due north at a speed of 60 kilometers per hour. If the van started off 6 kilometers directly east of the city of Evanston, how fast in radians per hour is the angle opposite the northward path theta changing when the van has traveled 12 kilometers? So it looks like we're looking at 6 kilometers east is where they started. So this is the town. And then it's traveling this direction. And we're looking at basically this is theta here. And we want to know how fast is this changing. So we're looking for d theta over dt. Now they tell us that the van's traveling 60 kilometers per hour, so we're going to call this h. So we're going to say dh over dt. So we don't know that, but we know dh over dt is equal to 60 kilometers per hour. So we can write a trig function to represent this. This would be a tangent function where we have the opposite over the adjacent. So we're going to write tangent theta is equal to h over 6, I'm going to say kilometers, but I'm probably going to drop the label for a little bit. So that's really tangent theta is equal to 1/6 h. So then I'm going to take the derivative on both sides of the equation. So I'm going to take the derivative with respect to time of tan theta equals 1/6 h. Derivative of tangent is secant squared theta, but I'm doing it with respect to time, so that'd be times d theta over dt. And then do the derivative of the right side, and you're going to end up with just 1/6, because derivative of h would be 1, times dh over dt. Now we're going to need to multiply the 6 across to find this. Actually, no, we're finding d theta, so we're going to divide by secant squared theta. Now we're going to have to do some algebra with this to kind of get it where we want it to be. So we're going to say that d theta, so let's divide each side by secant squared, we have d theta over dt is equal to 1/6 dh over dt divided by secant squared theta. And actually I want to write that a little different. I want to say d theta over dt is equal to 1/6 dh over dt. If I'm dividing by secant squared, that's the same as multiplying by 1 over secant squared theta, which then I can write that. I know that 1 over secant is actually equal to cosine. So I can write that as 1/6 dh over dt times cosine squared theta. Okay, now I've got to figure out what theta is at the specific moment that we're talking about. So they tell us that is the angle opposite the northbound path theta changing when the van has traveled 12 kilometers. So they're saying that h is 12 kilometers. So I can go back to this tangent theta and say tangent theta is equal to 12 over 6, which is equal to 2. So I have tangent theta equal to 2. So then I want to figure out, when does tangent theta actually equal this? So I'm trying to find theta here. Actually, I don't think that's the route that I want to take. All I need to know is what cosine theta is. If I know cosine theta, I can just plug in that fraction in for cosine theta. So I'm going to ignore this piece that I just wrote there. And I'm going to say, let's find this piece, because I know that cosine theta is going to equal, call this hypotenuse. So, well, we don't want to use h. Let's use s. So cosine theta is going to equal 6 over s. So if I find, that's s, not 5. So if I find, if I find s, then I will be able to plug it in there and I'll use that ratio down here for cosine theta. So I'm going to say that 6 squared plus 12 squared is equal to s squared. So I do 6 squared, which is 36, plus 144 is equal to s squared. I add 144 and 36. See if I can simplify it a little. So I get root of, this will be root of 180 is equal to s when I take the square root of each side. But I can simplify that. If I take out, let's divide by 9 first. So that'd be 3 root. If I took a 9 out of that, that'd leave us with 20. And then let's divide that basically by 4 so that I can take another 2 out. So that'd be 6 root. If I divide that by 4, I get 5. 6 root 5. So that's what s is. So I can write that as 6 over 6 root 5. Which then I can simplify that and say that that's 1 over root 5. So cosine theta is 1 over root 5. So then I can come down here, I'm going to slide up just a little bit, and I can write that this d theta over dt is equal to 1/6 times dh over dt, which they gave us dh over dt. It is right here, 60 kilometers per hour. And then I'm going to multiply it times cosine squared, which I got 1 over root 5 for cosine theta, so 1 over root 5 squared. So then, let's see, that's going to equal 1/6 times 6d is 10 kilometers per hour. But then I'm multiplying it times this here, this 1 over root 5. So if I square that, I get 1 over 5. So I end up with, and this is actually 1 over root 5. This is in radians. So, and it's radians per basically kilometer there. So it's going to cancel out this kilometer. So I end up with 2 radians per hour. That is d theta over dt.